Okay, I wanted to continue to work on similar triangles with you guys. So I've moved to page 36 and I want to create this little video for you guys to keep working on similar figures. So it says, take a look at the figure below. Identify, and let me change to yellow. Identify the similar triangles and then the values of the missing sides. Then it tells me AB is parallel to CD. Okay, so now I know, let me extend AB and CD. This line, AB, is parallel to this line, CD. So immediately, because those lines are parallel, we know that we have two pairs of alternate interior angles. We know that angle down here at A is congruent to this angle up here at D. And I'll go to another color. This angle here is congruent to this angle right there. This is by alternate interior angles. So let's go ahead and make ourselves a little statement over on the right-hand side. Angle EDC is congruent to angle EAB, and angle ECD is congruent to angle EBA. And these are alternate interior angles. And remember, when I find that two triangles are similar, I only need two angles to use angle-angle similarity. So now we know that triangle, I'm going to start at the blue angle. D, then I'm going to go to the pink angle, C, then to E, is similar to triangle. I'm going to start at the blue angle again. A, then the pink angle, B, and E. And this is by angle-angle similarity. Okay, so here we go. Now we know the triangles are similar. This means we can set up proportions that match the sides to one another. So we know that AB and DC are the same side. So this side here, nope, yellow is not a good color. Let's do green. We know that this side here is proportional to this side here. Now we need to match the other side. So let's do purple. We know that this side BE is proportional to this side over here, the other purple side. And then finally, let's use another color. I don't know, blue. No, there's already blue in the picture. Orange. We'll say that this side here is proportional to this side here. Let me fix this orange line so it's not coloring the actual side length. Okay. So now I'm going to set up a proportion to make sure it's crystal clear to everybody. Let's start by going from the left side triangle to the right side triangle. I'm going to go green over green. So that's 6 over 24 equals. Now I'm going to go purple to purple. 3 over X. I'm going to move this up. Sorry. I'm going to move this up a little higher. 6 over 24. So that was green to green. Now I'm going to go purple to purple. That'd be 3 over X. Now I'm going to go orange to orange, and that's going to equal Y over 20. So we have to solve two separate proportions. This is the only pair of sides that has two numbers associated with it. So we're going to do this in two steps. First, we're going to solve for the letter X, and then we're going to solve for the letter Y. So we're going to do two steps. First, we're going to set up a proportion that says 6 over 24 equals 3 over X. And then in step 2, we're going to solve 6 over 24 equals Y over 20. We will solve both of these proportions. In order to solve a proportion, you cross multiply. So that means that I would multiply 24 times 3 and 6 times X and set them equal to one another. So that would look like 6x equals, and then I multiply 24 by 3, and I get 72. Am I right? Oh, yeah. Yes, I am. Okay. And then I would divide both sides by 6 to solve for x. So x is equal to 12 units. So this side is 12 units long. We got to do it again to solve for y. So we're going to cross multiply again to solve for y. That means we're going to multiply 24 times y and 6 times 20. So that would give us 120, that's 6 times 20, equals 24y. So now on both sides, I divide by 24, and 120 divided by 24 is 5. So we get 5 is equal to y. So we just solved for x and for y in that picture. We also identified the two similar triangles. Let's look at example 3. If you need to pause, pause. In example 3, it says you are standing near a street light. Okay, so you're standing near a street light. Okay, so I'm here. I'm going to draw a little picture. Here's me, and here's the light. So I'm standing near it. The light pole is 30 feet tall. So this is 30 feet tall. Ooh, and I am 6 feet tall. This is new. I'm only 5 feet tall. I am 6 feet tall. The shadow the light casts is 50 feet from the light pole. How far are you from the edge of your shadow? Okay, so this question is a little tricky, but I want to make sure we can draw this picture. The shadow being cast from the light pole is like this. The light comes down like this and casts a shadow. So we are being told that the shadow the light casts, that's this shadow, is 50 feet long. How far are you, me, from the edge of my shadow? Here. So how far am I from the edge of my shadow? So if I were to look at this, this is two separate triangles, right? We've got the little blue triangle where I'm 6 feet tall and I have no idea how long that distance is. And then we've got the bigger triangle, I'm going to draw it in red, where this is 30 feet and this is 50 feet. So because as a person, I stand at a 90-degree angle to the ground, and because the shadow of the light is coming at the same angle, these triangles are similar triangles. So I want to go from the blue triangle to the red triangle when I set up my proportions. So I'm going to start with the number 6, and that is associated with the number 30. And I would set that equal to x over 50. So I went from the blue triangle to the red triangle, then from the blue triangle back to the red triangle to set up my proportion. Now, once I have my proportion, I can cross multiply, which means 6 times 50, that's 300, is equal to 30 times x, that's 30x. And then I would divide both sides by 30, and I would get 10 is equal to x. So my shadow is 10 feet long, 10 feet. Hopefully this was helpful and makes you feel a little better about solving problems that have to do with similar triangles.